So in this video, we're going to be solving trigonometric equations. That is some equation that involves trigonometric functions that are satisfied only by some value of a variable. So like you plug in like theta equals pi over 2, then that satisfies the equation, okay? The values that satisfy the equation, those are called solutions of the equation, just like in college algebra, okay? So let's determine first whether theta equals pi over 4 is a solution of the equation 2 sine theta minus 1 equals 0. Okay? So how do we determine if a theta value is a solution? All we do is we take theta, and everywhere we see theta in the problem, we replace it with pi over 4. Okay? So I have 2 sine, I'm going to plug in pi over 4, and minus 1 equals 0. So 2 times, now what is the sine of pi over 4? That's the square root of 2 over 2. If you're having trouble remembering this, you have got to memorize this from the unit circle. I cannot stress how important knowing the unit circle is. You're just going to have a hard time for the rest of this class, and then Cal 1, Cal 2, Cal 3 for the rest of your math career if you don't know the unit circle. So you've got to get it memorized, okay? It's not going away. So if I plug that in, guess what? That's not really working out too well for us because those 2's cancel, but I get square root 2 minus 1. And this is not equal to 0. So since this does not solve, this isn't a true value, this is false. Since that is a false statement, then pi over 4 is not a solution. So theta equals pi over 4 is not a solution. Well, how in the world are we going to figure out what a solution might be? Well, one thing we could do, we could try to solve for theta. So I have 2 sine theta minus 1 equals 0. How do I start solving for theta? I want to try to get sine by itself. So what am I going to do first? I'm going to add 1 to both sides. So I have 2 sine theta equals 1. Then I'm going to divide by 2. And so what does that get me? That gets me sine theta is equal to 1/2. What value gets me 1/2? Well, if you know your unit circle, so you know here this is 1, 0, so that's not it. But this here is square root 3 over 2, comma, 1/2. Up here you got 1/2, comma, square root 3 over 2. You see the symmetry here? And then 0, 1. So there is some symmetry in there. And once you get those 5 key points memorized, my goodness, people, that's all there is to it, okay? And really, it's pretty simple to memorize these. You're dividing by 2 every time. That first one is square root 0 over 2. The next one is square root 1 over 2. The next one is square root 2 over 2. The next one is square root 3 over 2. And the next one is square root 4 over 2. How do you say? Well, that's 0 there. That's just 1/2. This one here reduces to 1. Okay, so that's just a clever way to help you memorize those sine outputs if you're having difficulty there. So what does this tell me? That tells me that theta needs to be what? Pi over 6. So that's 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay? All right. Let's move on. Now, before we move on, though, there's one key point I want to bring up. This is a solution. This is a solution. Is it the only solution? Is this the only time that sine theta is equal to 1/2? Well, let's think about the graph of sine theta. Sine theta oscillates between -1 and +1. So from -1 to +1, right? The question is that the only time that sine theta equals 1/2? So y equal to 1/2 line? No, it looks like there are infinitely many solutions. Okay, there are infinitely many solutions. Okay, so how long is a period for sine? Sine has a period of 2 pi. So not only is pi over 6 a solution, but also any multiple where k is an integer of 2 pi, k is an integer, is a solution, okay? Now what about these solutions right here, that second side of the hump? Well, let's think about our unit circle that we have here. 1/2 is right there, but if I go on the other side of the circle, over here, this is -√3/2, 1/2. So there is another way to get it, theta equal to 5 pi over 6 over there, okay? So theta equals 5 pi over 6 plus 2 pi k is all of those other solutions, okay? So a lot of solutions, infinitely many, right? When you're talking about possible solutions for some trigonometric equation. So there's going to be two types of questions you're going to run into. Either it's going to say, give some general formula for all the solutions, so something like this, or it's going to say, we're going to restrict this to 0 to 2 pi, find all the solutions on this interval. Okay, so if that's the case, the only solutions would be pi over 6 and 5 pi over 6. Okay, so be careful, read what it asks you to do, and don't do any more than what it asks. All right, so this next problem, I want to solve the equation cosine theta equals 1/2. Cosine theta equals 1/2. I want to be given, so give a general formula. Let me do better. A formula for all the solutions. Okay. And then they say, list 8 of the solutions. Let's just list 4 solutions because 8's kind of crazy. Okay. All right. Now, what do we need to know for cosine? Well, one thing we could do is we could graph it. Cosine starts at 0, 1. It goes down to 0 at pi over 2. Then it gets to -1. Then it works its way back to 0. And then ultimately back here. Now, I'm going to do this real quick. That way I can copy. So let's duplicate here. So we're going this way, but we're also going this way. Now, does this thing ever cross 1/2? I think so. Okay, crosses 1/2 a lot, infinitely many times to be precise, right? So that's y equals 1/2. This is y equals cosine theta, or cosine x, we'll say. Okay. So that's the x-axis, y-axis going on there. All right, so now our job is to find the solution. So really all we have to ask ourselves is what angle produces 1/2? Well, heck, I can go right back to this picture I drew right up here, and it looks like 1/2 is going to be right here, so pi over 3. But I also have another one over here. Instead of it just being pi over 3, it looks like I might have another Okay, so this would be negative 1/2 square root 3 over 2. So that's not really going to work for us. We want it to be positive. So I think this is my value down here. Okay, so that's my value down there. Now, how would I get this angle theta? Okay, so it's pi over 3 short of being a full circle 2 pi. So what would that be? That'd be 2 pi minus pi over 3, which gets me, I guess that'd be 6 pi over 3 minus pi over 3, which is 5 pi over 3. Okay? So this value would be well, I guess in context of this, it'd be x equals pi over 3 for that first one. Okay? That's this one right here. And then the next one would be this negative pi over 3, which is 5 pi over 3 right there. Okay, so that would be x equal to 5 pi over 3. Now, how long is the period? The period for cosine theta is 2 pi. Okay? So if theta equals pi over 3 is a solution to this equation, then the general solution would be just add 2 pi multiples to that. Same here for 5 pi over 3 being another solution. If I add 2 pi k, I get all the general. So this is the general formula. Okay. Now it wants 4 particular solutions. So if I pick k equal to 0, that's pretty easy. That gives me theta equals pi over 3 and theta equals 5 pi over 3. If I picked like k equal to 1, that'd be theta equals pi over 3 plus 2 pi, and then I replace k with a 1, so that's pi over 3 plus 2 pi, which I can convert to 6 pi over 3. So that's 7 pi over 3 for one solution. And another one, 5 pi over 3 plus 2 pi, and then a 1. Gets me 5 pi over 3 plus 6 pi over 3, which is 11 pi over 3 for that theta there. So there are 4 particular solutions right there. And if you needed to get 8, you just keep running. Maybe pick k equal to 2 and just plug that in. That would be pi over 3 plus 2 pi, and then plug a 2 in. So now you got 4 pi plus pi over 3, and then you can work that math out there. Okay? So hopefully that gives you a better idea on how to get general formula, but also to get particular solutions from the general formula. So I want to show you last just how to do this in your calculator. If you go in, you can graph these. You can see I've already graphed some of these, but I'm going to regraph them. So I'm going to do the cosine of x for the first graph. I'm going to do 1/2 for the second graph. And I'm just going to graph it. And then you can see right there that clearly there are solutions. If you do second, calculate intersection, maybe left bound, right bound, okay? So the intersection, it says down here, it says the intersection P1 is 1.047, comma 1/2. So that gives me a theta of 1.047. Now, if I plug in pi over 3, into my calculator, we can see hopefully that that's going to be real close. So there we go. So there, it doesn't get you the exact answer, but it definitely lets you know that you didn't, that you can check yourself. Okay. So this is not, I won't accept that unless it says to do a decimal approximation. If you tell me that the solution is 1.047, that's not the same as telling me that it's pi over 3. This is exact. That's approximate. Okay, so I'm looking for exact there. So that's where you need to know your trig. All right, so most of the time, you know, our range is going to be between 0 and 2 pi, especially if we're dealing with sine and cosine. It may be like negative pi over 2 to pi over 2 if we're talking about tangent. So just, you know, keep that in mind, like, you know, what the what the domain of whatever they're restricting those solutions to be set to. Okay, we're going to do one more for this video. So I want to solve the equation 2 sine theta plus square root 3 equals 0 for theta stuck between 0 and 2 pi. Okay? So in interval notation, it looks like this. Now, to do this, I try to get theta by itself. So I'm gonna subtract square root 3, subtract square root 3, get 2 sine theta equals minus square root 3. Divide by 2, divide by 2. So I have the sine of theta is equal to negative square root 3 over 2. When I think about a unit circle, sine is negative. It's negative down here in the third and fourth quadrant. Okay, the y value is less than 0 down here. It's greater than 0 up there. That's how I know it's negative. Okay, remember all students take calculus. So sine is positive there, and it's positive there in quad 1 and quad 2. So if it's a negative, I know it's got to be in Q3 or Q4. Okay, so what angle theta gets me these values? Well, let's think about this for a second. The sine of square root sine of theta equals square root 3 over 2. That's up there. That's a pi over 3 angle. Okay, remember you get the 1/2 and then square root 3 over 2. So if that gets me going this way, then going down this way, that's negative pi over 3 with our symmetry. Okay, so this angle down here is going to be coming from 2 pi minus pi over 3. Okay, 2 pi minus pi over 3, that gets me 6 pi over 3 minus pi over 3. That's going to be 5 pi over 3. Okay, so this one of them, my answers is 5 pi over 3. Okay, now the other answer here, so if this is going over here, that's pi. If I could add one more pi over 3 to that, I can do pi plus pi over 3. So that's 3 pi over 3 plus pi over 3, which is 4 pi over 3. So my other solution is 4 pi over 3. So you either build that out like I just did, or you have it, you know, your big old picture of your unit circle, or you've got it memorized or whatever. Good for you if you've got it memorized. So my solution set on this interval, you think about it, the only place where the sine curve on 0 to 2 pi is equal to negative square root 3 over 2 are those two places right there at 4 pi over 3 and 5 pi over 3. Okay, those are the only theta values where I have the negative square root 3 over 2 line equal. Okay, so I'm just going to write the solution set is, and then my little curly brackets, 4 pi over 3, comma, 5 pi over 3. Close my little curly brackets. Okay, little curly brackets is set notation, or you can put your numbers inside those little curly brackets. That tells you that there's two solutions. Okay? One thing you got to be careful with this example, if you used a calculator and you did the sine inverse, so say you got here, and you did, theta equals the sine inverse of negative square root 3 over 2. And the result given is negative 1.047. Okay? Now, what do you know about negative 1.047? Ooh, that looks really familiar, right? That's like negative pi over 3. Okay, what's wrong with that answer? Because if you remember, this thing, the output is stuck between negative pi over 2 and pi over 2, right? But your answers here are between 0 and pi over 2, or 2 pi. So the negative pi over 3 is not in the interval. So if you use a calculator here and they tell you the interval, you better make sure that your solution even falls in your interval. And by the way, those are between 0 and 2 pi. Okay, so both of those fall in our interval where we want them to. So just keep that in mind as you're working through these problems, okay? If you're going to check yourself in the calculator, you may not get the same answer that you got when you're doing it, with your noggin, okay?